Hello everyone, I hope you're all doing well. Today we're going to start on Chapter 3. We're going to look at 3 claims and 4 validities, interrogation tools for consumers of research. And so for our broad overview here, we're going to be looking at 3 basic types of claims, so frequency claims, association claims, and causal claims. And these 3 types of claims are basically going to be 3 broad categories of research, 3 different ways that you can try and look at different kinds of data. And then to evaluate those 3 different types of claims, we're also going to look at 4 main validities, sort of ways that we can evaluate and assess the quality of our claims. And these validities include construct validity, external validity, statistical validity, and internal validity. So the first thing that we're going to do, if we're going to be talking about types of experiments and how we can evaluate those experiments, we're going to start at the basics and talk about variables. And so a variable is something that changes or varies, hence the name. And a variable is going to need to have at least 2 levels or values because it needs to have that option to change. So a variable can be pretty much anything in an experiment that you're going to measure. Sex could be a variable where you can have male or female. Weight could be a variable and you have all of the options of things, of weights that things could have. And for these variables, we can divide them into 2 broad categories. The first being measured, and the second being manipulated. So a measured variable is something that can be observed and recorded by the researcher. So it's something that's going to be sort of set in stone, and it's something that we're just going to measure. So my first example of a variable as sex would be a measured variable. It's something that is just measured, you're not doing anything with it. Other examples could include height or hair color. Psychologists will start looking at measured variables that are a little bit less concrete and more abstract. Focus on things like depression or stress levels. If we're measuring those, they can be a measured variable. Our other variable is a manipulated variable, something that is controlled or manipulated by our researcher. So if a researcher is in control of a variable, usually this means that you're assigning a participant to a level of the variable. And if you're familiar with how we set up experiments, that would be, say, assigning someone to a condition. So if we were looking at drug levels, maybe we were studying how something changes in response to drugs. And so you would have your control group that has no drug. Maybe you have a low dose group that gets a small dose of the drug, and a high dose group that gets a larger dose of the drug. So that variable of how much drug is given to these people is manipulated by the experimenter. And so quantity of drug is our manipulated variable in that situation. Now, it is good to note that some variables can only be measured, not manipulated. So like our first example, talking about sex, we can't really go about changing that for the sake of an experiment. So you can't really assign people to a different sex. You can't assign people to a different age category. That's just something that occurs. So some variables have to be measured just by the nature of what they are. In other cases, certain variables could be either measured or manipulated, depending on how the experiment is set up. Now, the variables that we've been talking about, things like age or weight or sex, are things that are pretty easy to measure. If you want to get the weight of something, you put it on a scale and report that weight. Maybe you're going to report it in kilograms, maybe grams, but there is sort of a standard of how we can measure that. Now, in psychology, not all of our variables easily fall into categories like that. And so we can run into what are called conceptual variables. And these are conceptual because they're abstract concepts, and sometimes you would hear them called a construct because it's something that we're constructing, something like happiness or depression. So those are things that are really hard to quantify and measure, but a lot of psychology is based around trying to study and therefore measure some of these conceptual variables. And so in order to try and study something like happiness, you're going to have to turn it into something that we can measure and talk about. And that would be an operational definition. So we can turn our concept of interest into a measurable or manipulatable, there we go, having trouble with words today, manipulable variable. So if you want to look at the happiness as your conceptual variable, your operational definition would be to measure happiness as the number of times someone smiles in an hour. So you're telling someone who's looking at your research how you have defined the thing that you're trying to measure. So how are you going to measure happiness? By recording the number of times someone smiles in an hour. Now we can look at a couple of examples that help us solidify our understanding of this idea of changing a conceptual variable into an operational definition that we can then use in our research. So here, a table from our textbook, we're just going to look at a couple of examples. So here, our variable name or our conceptual variable is car ownership. So their operational definition, so how are they going to measure this, is researchers asked people to circle, I own a car, or I do not own a car. That's how they measured car ownership. And so from the way that this is presented, we know that there are two levels of this variable. Either you own a car or you don't own a car. And because this is something that the researchers aren't manipulating, they're just measuring it, this is a measured variable. We can jump down here to a different experiment. And our variable name here is type of story told about a scientist. And in this situation, our operational definition, the way that they were measuring what type of story was told, researchers assigned participants to read stories about Einstein and Curie, which related either to work struggles or achievements. So we have two levels in this case, a story about a scientist's struggles and a story about a scientist's achievements. So you can tell which one they read because they were given one or the other. And this word here being assigned, as opposed to asking or measuring something, tells us that this variable here is manipulated because the researchers gave the participants one story or another. So this is a manipulated variable, not a measured one. And there are other examples here that you can go through, but we've done enough reading through things. Now we've talked about and seen some examples of how we can operationalize a definition. So how we can turn a conceptual variable into an operational definition, but we didn't really talk about what are some of our options for doing this. So if you're trying to measure something abstract, something like happiness or depression or number of cars you own, which is less abstract, but you have a couple of different ways that you can measure that you can give your operational definition. So like we just saw, they have sort of an example of how you could operationalize this definition. by either assigning one or the other type of story, by asking people to circle a response on a survey. Those are pretty common things to see in psychological research. So talking about surveys, you could have a self-report questionnaire. So they give you a question and give you a couple of answers that you can pick from. And these are great because you can do them online. So if you're a researcher and you want to collect a bunch of survey data, you put together basically a multiple choice test and send it out to people. You could ask, what types of grades do you usually get? And then people can click the response that most closely matches them. So that's one way that you could have an operational definition, this survey, to measure a variable like how do you perform in school? How well do you do in school? Another way that we could get at the same conceptual variable of our school achievement or performance in school, you could check the records. So instead of surveying someone, maybe you just go to the school and look at their transcripts, see how well someone performed. And then another way, again, to get at school achievement is you could look at some teachers' observations. Maybe the teacher fills out a questionnaire, or maybe the teacher just jots down some observations. Are their assessments positive or negative? So there are lots of different ways that you can have these operationally defined variables. So you can get at the same conceptual variable, the same basic idea, a bunch of different ways. And the fact that you have lots of different ways that you can get at the same concept is why when you're conducting research, it's so important to go into details, especially in your methods section, and explain how you're measuring everything. You have to give an explicit definition, that operational definition of everything that you're doing, of everything that you're measuring, so that others know what methods you used in your experiment. And so that's sort of our basic groundwork of understanding how variables work. And now we're going to get into, as promised, our 3 distinct type of claims. And so these are going to be, again, those broad types of research that you can do. In this class, each type of claim, our frequency claims and association claims and causal claims, they're each going to get a distinct section of the class. So we're just going to talk about them very, very briefly today, with the understanding that we're going to give them a lot more attention for each of them as the course goes on. But we want to look at sort of the big picture of where we're heading with this course. And so a claim, first off, is going to be some kind of argument that someone is trying to make. So scientists will use data to test and refine their theories and claims. And so our first type of claim is, like we said, a frequency claim. And a frequency claim is going to be a single variable. How often does X happen? And we can look over on the side here for examples of each type of claim. So a frequency claim would be 1 in 4 teens admit to texting while driving, or 42% of Europeans never exercise, or middle school kids see 2 to 4 alcohol ads a day. All of these are giving us a measurement, a frequency of a single variable. Our next type of claim are association claims. So instead of just looking at a single variable, association claims are looking at 2 variables that are related to one another. And for our examples, we're saying, okay, well, single people eat fewer vegetables. And so with this one, we're saying that single people eat fewer vegetables, and it's understood that they're going to be eating fewer vegetables than people who are not single. When we're quantifying this sort of relationship, fewer vegetables, then what? And you can usually figure out what they're getting at. So fewer vegetables than non-single people eat. And so we're comparing or relating a person's marital status and how many vegetables they eat. We're forming an association between those two variables. For our next one, angry Twitter communities linked to heart deaths. So we're saying that there's an association between the type of Twitter community you're part of and the type of death you're more likely to experience. So if we're seeing a link between two related variables, it's an association claim. And then our last type of claim is a causal claim. So we're still looking at two variables, and they're still related to each other, but a causal claim goes one step further, and instead of just saying that A and B are related, like we've said in the association claims, causal claims imply a direction for that relationship. So a causal claim is saying specifically that A causes B, whereas an association claim would just say that A and B are related. So an association can't give us direction, but a causal claim gives us a direction, a cause. So that's how we're going to differentiate between those two. And again, over here we have causal claim examples. Music lessons enhance IQ. So more music, more of A causes more of B, a higher IQ. Babysitting may prime brain for parenting. So more babysitting leads to better performance as a parent. So we're seeing that directionality, and we can talk about it as enhancing or increasing or improving some kind of direction there where one is causing something in the other. And we're going to talk about these again in more detail now and throughout the rest of the course. But we're going to go into just a little bit more for each of these types of claims. So like we've said, frequency claim describes a particular rate or degree of a single variable. And this is only one variable, and specifically, it's a measured variable. So if you're looking at an experiment where the results are a frequency claim, if the results of this study give us the idea that, say, 15% of Americans smoke, then that experiment involved measuring a single variable. So they asked, do you smoke or not? And they got the answer that 15% of people surveyed said yes. For our extra details about association claims, for an association claim, one level of one variable is likely to be associated with a particular level of another variable. And so, of course, we're talking about at least two variables. And again, with association claims, we're looking at measured variables. So because we're just forming a link between two things, we're not getting that directionality that comes from a causal claim. We're still using measured variables. And so if you find two measured variables that have an association with one another, if they're associated, you can say that they correlate or co-vary with each other. So we had our examples on the previous page, but another one could be people who multitask are worse at multitasking. So people who don't multitask are better at multitasking. There's lots of random headline examples that come from the textbook. And when we're talking about this correlation, they're going to change together. They vary together. And we can have a couple of different types of correlations or different types of associations. They can be positive, negative, or zero. And we can see a couple of visual examples about that on the next slide here. So here we're seeing what's called a scatter plot. And so we have all of our points of data represented on this graph here, where each axis is telling us a different type of information. So here on our x-axis, we're looking at the amount of gratitude expressed. So how grateful are people? And then on our y-axis, we have relationship longevity. So how long are people in a relationship? So this graph here, this scatter plot, is telling us the relationship between how long people are together in a relationship and how much they express gratitude. And so when we look at all of these dots kind of scattered about, usually when you're seeing a scatter plot like this, you'll also see something called a trend line. And a trend line is going to give us kind of a line of best fit, a slope of the data. And here I can actually draw in what our trend line should look like. Of course, there are ways to calculate this so that it's more accurate, but my awful drawing skills can give us a line that runs somewhere down the middle of our data. And so we're saying that this line is as close to as many of these points as it possibly can be, which is why it's called a best fit line or a trend line, because it's showing the trend or the direction of our data, which is a little bit more than we need right now, but that's all right. So this is a positive association because we're specifically seeing this upward sloping line. And so what this is telling us is that the longer you're in a relationship, the more gratitude we'll see expressed. So scoring high on this axis gives us a high score on this axis. And we can take the converse of that, saying that a low score on this axis should give us a low score on the other axis. So in a positive association, a high score on one of our traits should correlate or give us a high score on the other. Clean that off. And so next we can go and look at a negative association. And at this point, you might be able to figure out what we're going to see in this case. And we can draw in another trend line, a line of best fit, not too shabby. And in this case, instead of seeing that upward sloping line, we're now seeing a downward slope. And that downward slope is telling us that there's a negative relationship. So instead of with what we saw in a positive association, where a high score on one means a high score on the other, for a negative association, a high score on this axis is going to give us a low score on the other axis. And we can go the other way. So a high score on our x-axis gives us a low score on our y-axis. So a negative association is the opposite of what we would have expected from a positive association. And clean that off. And then the last kind of association we can have is a zero association. And in a zero association, you end up kind of seeing a mess. So your scatter plot is going to put dots pretty much everywhere. And if we tried to put a line of best fit here, if we tried to find a place that I could draw a line that gets close to as many of these points as possible, it doesn't really work. That doesn't seem to fit, and this doesn't really seem to fit. Maybe this. None of them seem to be very good. And the reason for that is that there is no association here. So there's no link between these two variables. And so in a zero association, you can't really have a line of best fit because there's nothing to fit it to. And so you see this cloud of random points in your scatter plot. And so we'll be able to tell the difference now between these different types of associations. So if I described an association in which a high score on one variable correlates with a high score on another variable, you should know that I'm describing a positive association. Now, causal claims didn't actually end up with a slide of their own, because causal claims, strangely enough, are one of the types of claims that we're most familiar with. So we've already said that causal claims, we're saying that one variable is responsible for a change in another variable. We're implying that cause or directionality in the relationship. Now, this kind of directionality can only come from doing experimental research. So when we had talked about our frequency claims and our association claims, we stressed the fact that those are only using measured variables. But a causal claim will be using a measured variable and a manipulated variable. So this is where we're experimenting or manipulating the situation. And that act of doing the manipulations is what lets us produce or claim that there's one direction of this relationship. So if we're looking at the example of people with different levels of a drug in their system, maybe we want to look at people's stable weight and how much of a drug they're taking. And so we can measure people's weight when we can manipulate how much of a drug they're given. And so we can then compare and see how much people in the group that had no drugs compares to the weight of the people in the group with a small amount of the drug, and how it compares to the weight of the people with lots of the drug. And if we see that the people in the group where they got a lot of the drug, if that weight is lower, then we're saying that that drug is causing weight loss because we've manipulated people to have different exposures or different amounts of that drug. And so when we're talking about causal claims, we're always going to be talking about an experiment where we've manipulated one of those variables. And so when we're talking about associations and causal claims, I've stressed the fact that both are going to be talking about relationships between two variables, but an association claim is just saying that there's a relationship. The causal claims are the ones that are giving us a direction, saying that one variable causes the other. And so this is a handy chart that the textbook has given us, which gives us some hints about words that you might see in a study or maybe in an exam question that would tell you if they're describing an association claim or a causal claim. So for an association claim, they might say that A is linked to B. Variable A is linked to variable B. A is associated with B. A prefers B. A may predict B. So these are saying that there's an association, but they're not saying anything concrete about which direction the association goes. And then if we go to the other side, our causal claim verbs are A causes B, or A affects B, A changes B. So if they're talking about something concrete and implying that one variable is affecting another variable, then we're going to say it's a causal claim. Now they give us some weird verbs in here. in an exam type situation, I would probably never say something like A fights B or A distracts B. That seems a little bit abstract. We'd probably stick to things like causes or effects. But these are kind of useful when you're trying to pull apart what, say, a newspaper article is talking about. These could be some hints as to whether they're talking about an association type study or a causal study. So now that we've gone through our types of claims, those 3 broad categories of research that we can talk about, now we want to look at how we can evaluate or critically think about those 3 different types of studies. And our textbook publishers have narrowed down 4 ways that we can critically evaluate those different types of studies. And sometimes some of these validities, these ways of thinking critically, some are going to apply more to some of the claims than others. So we'll break it down for which validities are most helpful for each of the 3 types of claims. But first, we need to actually establish what these 4 validities are. And so our 4 validities are listed on the side here. So construct validity, external validity, statistical validity, and internal validity. And we're going to talk about each of those. So our construct validity is talking about how well the variables in a study are measured or manipulated. So the extent to which operational variables in a study are a good approximation of the conceptual variables. So these are talking about how well constructed, how solid is the experimental setup. Did the researchers do a good job setting up the experiment so that the variables are well measured and manipulated, and that the operational variables, our operational definitions, are a good way of getting at our constructs? Next is our external validity, and this is the extent to which the results of a study generalize to some larger population, or to other times or other situations. So if something is externally valid, it means that we could apply the results of one study to a much broader area. So they're saying here an example of if you've looked at, say, a population of school children in Wisconsin, and you're looking at how well they're learning, or how much their learning improves when you're using a specific type of lesson strategy. And if you've conducted this research, and in this one school, in this one town in Wisconsin, their performance has improved because of the strategy you're using, if that study is externally valid, you would be able to take what you found in Wisconsin and say, this method of lessons should improve performance in other places as well. So you could apply it to a broader population. And a lot of studies rely on external validity because maybe you don't have the budget to study all school children in the US. Maybe you only have the funding to study that one school in Wisconsin. But if something is externally valid, then you can apply those results more broadly. If it isn't externally valid, then the results of that study only apply in the population you tested it in. So maybe there's something strange about Wisconsin, and the type of learning only works in Wisconsin. So that would be a not externally valid study because it can't be applied anywhere else. Our next type of validity is the statistical validity, the extent to which the data supports the conclusions. So this is going to cover a lot of different things, but among other questions, it's important to ask about the strength of an association and the statistical significance of what you're seeing. And of course, we're going to talk at length about strength of association and statistical significance throughout this course, but for right now, we're just going to say that we're looking at how well is our line of best fit fitting our data, how close is all of our data clustering to that line I drew on our scatter plot, and how sure are we that the results are valid. So this is just saying, how good are your statistics? Is your data good, and have you evaluated it well? And then our last point is internal validity. And kind of makes us think of external validity, but internal validity is looking internally. So in a relationship between two variables, A and B, internal validity is the extent to which A, rather than something else, is responsible for changes in B. So if we're studying this relationship between A and B, how sure are we that we're actually studying what we're meaning to study? How sure are we that A is causing B and something else isn't involved, something else isn't driving this relationship? So how certain are we of the results that we're seeing and the associations that we think we're describing? So how sure are we of what we're looking at? And so we're going to go through each of these types of validities and how they relate to being critical about our three types of claims. So if we want to look at frequency claims, if we want to critically evaluate or interrogate a frequency claim, we're going to consider mostly looking at the construct validity and our external validity. Maybe we care about the statistical validity, but a little bit less so. So for our construct validity, we're caring about how well is the conceptual variable being operationalized. So if we want to take an example, if we have the frequency claim that 80% of college students have been depressed in the last year, if we're evaluating the construct validity, we might ask, how was depression operationally defined? How were the researchers measuring depression? Was it a good measure of depression? How sure are we of the quality of the construction of this study? For our external validity, and you'll sometimes see external validity called generalizability, because external validity is asking how well the results of this one study can be brought into other situations. How well do the results generalize from our study population to a broader scenario? And so again, we can have an example. If we say 72% of the world smiled yesterday, well, they're claiming that they can talk about the whole world as their sample, but who are they really looking at? Did they study people from multiple countries, or did they just look at a small subset of maybe undergraduates at a single university? Where was their sample taken, and why do they think that they can apply it to the whole world? And then for our last one, if we wanted to talk about statistical validity, we're looking at how much we trust the study's conclusions, how sure we are of their statistics. And so again, another example. So if we have a report that 41% of teenagers text while driving, if that research is accompanied by a quantifying number, maybe they're going to give us a p-value. Maybe they're going to give us a spread of their data. Maybe they're going to show us a graph where they can give us sort of how they measured this and what their data looks like. So the more information that we're given, the more certain we are of the validity of their statistics. And again, we'll talk about statistics ad nauseum throughout this course, but in the most cases, more statistics is going to be better because it's going to give us a little bit more than just the number that they put in the title. So 41% is fine, I guess, but if you tell me that your p-value is very, very small, which means that you are absolutely sure that that's a real number, that your statistics were done right, then maybe I'll be a little bit more impressed. So that was for our frequency claims. For our association claims, it's gonna look fairly similar. We have construct validity is still important. The reason why I've said it again here is that construct validity now applies to both of our conceptual variables. So for frequency claims, you're only looking at the one variable that they're measuring. But in an association claim, now they're looking at measuring two variables. So you have to check that both were well defined and that their method of measurement was good in both cases. And again, for external validity, how well are we sure that their claim can apply to a larger population? So the same kind of critical thinking there. But when we get into these association claims, our statistics start to matter just a little bit more. Because with a frequency claim, if you're only looking at one number, the statistics are a lot simpler. And so sometimes they can be overlooked and it's not a huge problem. But as we get into more complicated setups where we have two variables now, it gets a little bit more complicated. So we're still going to focus probably on strength and significance. So strength of the relationship here is talking about how our dots on the scatter plot are associated with each other. And significance being, again, how certain we are that what we're seeing is because of the things that we're measuring. And this will, again, make more sense when we start getting into things like calculating the strength of a correlation. In statistics, you would have talked about an R value, looking at how closely our points on a scatter plot cluster to our best fit line. And this is less important for this part of the chapter, but I'm going to draw it in just in case it jogs some memories. So if we have our scatter plot again, and this is going to be a positive correlation, if your dots on the scatter plot are sitting really close to your line here, we would say that this is a pretty strong correlation. There's a very strong relationship between those two variables. But if I can move some of our dots, if we see something kind of like this, that's looking a little bit closer to what we had for our zero correlation. So it's still positive, there's still that general upward trend, but our relationship is less strong. So we'd have a much lower R value and our strength of the relationship would be weaker. So this second option is a little bit less good than the first in terms of statistics. And we'll get into calculating that later on. But when we're looking at statistical validity in association claims and even into our causal claims, we have to worry about two specific kinds of error. So the first kind of error is type 1 error. And this is what would be called a false positive. And so for a type 1 error, you assume that there's an association where one doesn't exist. So because of random noise in your data, you've said that there is a relationship between variable A and variable B, but in reality, there is no relationship. Our second type of error is called type 2 error. And this one's arguably almost worse. And so instead of a false positive, a type 2 error would be called a miss. So you run your statistics and you make the conclusion based on those statistics that there isn't an association. You say that there isn't a link between A and B, but in reality, there is an association. Your data just didn't capture it. So this one's really tough because maybe your sample size was too small, or maybe by chance you just got a weird sample of your population and you missed seeing an association that was there. So these are two types of error that we have to watch out for, and we'll keep talking about these in more and more detail as we go through the course and start talking about the specifics of stats. Now, we've talked quite a bit about the difference between an association claim and a causal claim, and the fact that it both involve two variables. But a causal claim is a little bit more strict because it's giving us that direction, that statement that A causes B. We actually have a couple of criteria that have to be met before we can go so far as to say that A causes B. And so our three criterion that we have to hit, so the first is that we have to see covariance. So a study has to show that as A changes, B also changes. So if we made up a scatter plot of our data, a different level of A should correlate with or covary with a change in B. They should change together or covary. The next thing that we also have to see is temporal precedence. Temporal meaning in time, precedence meaning that one has to occur before the other. And so in our study, we should have the methods set up so that we ensure that A comes first in time. So if A is causing B, then we should measure A first and then measure B. So that temporal precedence has to be taken into account, and we have to see that in our results as well. And then our last point brings us back into internal validity. So we have to be sure that A is related to B and there isn't something else driving this relationship. So to be sure that A is causing B, you have to know that your study is internally valid and that there isn't some third variable, variable C, that's driving this relationship. So you have to know, or at least be reasonably certain, that A is causing B before you can make the claim that A is causing B. And these are fairly logical concepts, but we do have to put them on paper because these are things that have to be met before we can actually call it a causal claim. Otherwise, we have to stick with the more relaxed language of an association until we can do the experimental manipulations that let us meet these three different criteria. And so when we get to our interrogation of causal claims, we're seeing what we basically just saw for our association claims. We still care about construct validity, we still care about our external validity and our statistical validity, but we have to keep in mind that the internal validity was important to differentiate a causal claim from an association claim. So even though we don't mention internal validity anywhere else, this is where it's particularly important, and it's why we talk about it. So at the very end here, we've had these 4 different validities, and these are things that we're sort of striving for in our research, but sometimes you can't have everything be perfect. You can't always have a perfect internal validity and external validity and statistical validity and construct validity. So with all of these, which one is the most important? And the answer is kind of a cop-out, because we have to say it really depends. So what kind of claim are you trying to make? So what kind of study are you running? And each researcher will have their own priorities. Maybe one researcher is really focused on statistical validity, and they're not so concerned that their study isn't externally valid. Maybe they don't care that you can't generalize their research to the whole world, but they feel that if they do a really good job on statistical validity, then they're very certain about what their results mean for a small population. So the researcher can choose that that's okay with them. So the answer is that there really isn't an answer. All of them can be important, and we should consider all of them, but priorities shift, and that's why it's important for us as research consumers to be aware of some of these validities and some of this critical thinking that comes with them, so that we know that we're reading the science the best way that we can, and that we're thinking critically about it with a good knowledge base. And we will leave it there for chapter 3.